Hello, ladies and gentlemen. Welcome to Math 20-1, Chapter 2, Lesson 3, Adding and Subtracting Radicals. Probably Part 1. Now, today we're going to solve problems that involve operations on radicals and radical expressions with numerical and variable radicands. And we're going to solve problems that involve radical equations. Well, we'll do that eventually. Now, first thing to notice, we can add and subtract radicals as long as the radicals are the same. I think of this like money. You come home from Mexico, woohoo, you've got 9 pesos in one pocket and 5 pesos in the other pocket. How many pesos do you have? Well, 9 and 5 is 14 pesos, or 14 square root 2. You go through another pocket, you have 8 American dollars, and you find an IOU for 5 American dollars. How much do you have? Well, 8 minus 5 is 3. So, 8 cube root x minus 5 cube root of x will be 3 cube root of x. Now remember what I said about the same? You have 5 square root 3 plus 2 square root 3 minus 6, the 4th root of 3. And you're going, wait a minute, this is 5 pesos and 2 pesos, so that is 7 pesos. And you have an IOU for 6 American dollars. Okay? So as long as the radicals are the same, you can add them, but if they're not, you can't. And note the square root of 3 is different than the 4th root of 3, or the cube root of 3, or the square root of 8, or whatever. So I'm going to pause the recording, and you add up like radicals here. Okay? Add them up. We'll come back and compare results. Welcome back. 8 square root 7 plus 5 square root 7 should be 8 and 5 is 13 square root 7. 7 cube root 4 minus 5 cube root 4 plus 2 cube root 4. 7 minus 5 is 3 plus 2 is... Sorry, 7 minus 5 is 2. 2 plus 2 is 4. And the third one, notice you have different terms or different radicals. And green diamonds around the square root of 10. We have 8 square root 10. And blue circles around the cube root of 2. 11 minus 6 should be 5 cube root 2. Right? So that's adding and subtracting radicals. That's honestly most of the lesson, but not all. Because how would I be a little tricky here or make you think? Simplify. So if I ask you to add square root of 27 plus square root of 12, you're going, I can't do that. But last lesson we talked about simplifying. 27 is 9 times 3, which is 3 times 3. So this is 3 times 3 times 3. Now this is the square root of 7, so we're looking for pairs. So that's 3 squared times 3, or 3 square root 3. So the square root of 27 is 3 square root 3. 12 is 4 times 3, which is 2 times 2. That's 2 squared. Now, just double checking, we're looking for pairs or square roots. So this is 2 square root 3. So once we simplify it, 3 square root 3 plus 2 square root 3 is 5 square root 3. All right? So most of the time, and mark my words, most of the time, when I ask you to simplify radicals, or to add them, you can usually simplify them. And you should have like terms in there somewhere. So I'll do this one with you, and then we're going to go on and I'll let you do some on your own. So here we go. 2 cube root of 54 minus 3 cube root of 16. Well, right off the bat, 54 is 9 and 6. Now this is cube root, so I'm looking for groups of 3. So this would be 3 cube root of 2. So this is, all right? So this is 2 times 3 cube root of 2, which is 6 cube root of 2. Actually, I should rearrange this, give myself a little more space, the advantage of using a smartboard. There we go. So the first term is 6 cube root 2. The second term 16 is 4 and 4, which is 2, 2, 2, 2. 2 times 2 times 2 times 2 times 2. Now, once again, it's a cube root, so I'm looking for groups of 3. So the cube root of 2 cubed is 2, and I have 1 cube root of 2 left over. So this is minus 3 times 2 cube root of 2. So that's minus 6 cube root of 2, which is, so the whole thing is 0. Now what I have not told you is that you can check your answers with your with your calculator. 2 cube root of 54 minus 3 cube root of 16. Oh, come on, faster. People are watching. So, 2 math cube root of 54. Oh, sorry. On this version, I have to go. Oh, stop that. Minus 3 math cube root of 16, 0. Right? And notice how the calculator puts my radical in brackets to emphasize that it's cube root, not 2 times 3 or 6 3. Anyway, it's 0. That's the answer I got. So you can always check your work. Do not give me decimal approximation as an answer. Now, if I happen to have a letter in there, remember we also talked about simplifying letters. Now 5 is prime and A is just A. There's nothing I can do. 75, on the other hand, is 5 times 15, which is 3, 5. This is 3 times 5 times 5. Now it's a square root, so I'm looking for pairs. So that should be 5 square root 3. So this is 3 times the square root of 5a plus, now 75 becomes 5 square root 3. And don't forget my a. Now, here I forgot my a, so I'm writing this as a separate term. I really should just write that as 5 squared 3a. And here I stop because 5 square root of 5a is a different radical than the square root of 3a. Remember I said most of it you can almost always simplify, but they're not always the same. You can't always add. And here we go. And this is a standard trick question. People go, oh, 8! 8a or 8 square root 8a or 8 square root 5a or something. Yeah. Read the question. Be careful. All right? Now, I'm going to pause the recording. I want you to simplify each of these terms. Now, also remember, if we've done square root of 27 already, it's 3 square root 3. I don't need you to show all the work again. All right? So some of these easier ones, you do them often enough, you realize what they are. So pause the recording, come back, we'll compare results, okay? Welcome back. 8 square root 32 is 8 times 4 root 2, or 32 root 2. 3 root 18 is 3 times 3 square root 2, or 9 root 2. And 4 square root 27 is 4 times 3 root 3. We showed 27 earlier, so that's minus 12 root 3. So the answer, and I should get in the habit of putting my answers in a box just to emphasize it, 41 square root 2 minus 12 square root 3. All right? That's about as nasty as it gets. If you can handle that, I'm happy. Now, of course, how am I going to challenge you a little bit? Well, a question like this, what's the missing side? Well, here you use what? Mr. Pythagoras. A squared plus b squared equals c squared, where a and b are the short sides. I'm going to call this a, I'm going to call this b, and I'm going to call this c. So this is a squared plus square root of 14 squared equals square root of 26 squared. So the square root of 14 squared is 14. Square root of 26 squared is 26, so a squared 20 is 12. I'm not showing you 26 minus 14. Your math 20-1, you should be able to handle that. Now, have we done square root of 12 before? I thought we had. 416. Yes, we have. That's 2 square root 3. As I said, I'm getting lazy, and if we've done it already, I don't see the need to redo the calculation. So that is 2 square root 3. That's the proper, sorry, I'm sorry, a squared is 12. A is the square root of 12, which is 2 square root 3. My apologies. All right. Now, that's it. And if you, well, that's half the lesson. If you've got that, you should be able to handle the nastier questions I'm going to throw at you in the next half of the lesson. Got any questions, shoot me an email. Otherwise, let's go on to the next part. Good luck.